Today we will learn about frequency polygon. In the previous video, we learned to represent classified data as a histogram. Like the histogram, frequency polygon is also a way of representing classified data graphically. In this video, we will look at two ways to draw a frequency polygon, using a histogram to draw a frequency polygon and frequency polygon without a histogram. Let us learn to draw a frequency polygons with the help of histogram. Suppose the height of students of class 9 in a school are presented in this frequency distribution table. This distribution is a continuous frequency distribution because there is overlapping of class intervals. From the frequency distribution table, we can draw a histogram like this. Pause the video and think about it. Let's go ahead. To make a frequency polygon, first we need to find the midpoint of upper side of each rectangle. Midpoint of class interval 120 to 130 will be 125. Therefore, we will go to the upper side of the rectangle drawn on the class interval 120 to 130 and mark the middle point, followed by the vertical line representing 125 on the x-axis. 125 is the midpoint of class interval 120 to 130. We also call it a class mark. Let P be the middle point obtained. Here, the coordinate of point P are 125 and 5. Similarly, we will find the midpoint of the upper sides of all the rectangles. We assume that the class interval before 120 to 130 is a hypothetical class interval of 110 to 120 with a frequency of 0. That is, the height of any student is not in this class interval. Similarly, we also assume that after the class interval 160 to 170, there is an imaginary interval of 170 to 180 and its frequency is 0. We will mark their midpoints. Now, we will connect all midpoints with the line segment. This gives us figure OPQRSTU made of line segments. On careful observation, you will come to know that this shape is a polygon whose vertices represent the corresponding frequencies of class intervals. Since the frequencies of class intervals are represented as vertices of polygon, we call it a frequency polygon. Here you can see that the triangle located outside the line graph can be arranged inside the line graph in this way. This shows that the area of frequency polygon is equal to the area of histogram. In this way, the class interval of 0 frequency helps us to equalize the area of frequency polygon equal to the area of histogram. Now you know about histogram and frequency polygons. Can you tell the difference between the two? Think. Let us tell you. Data is represented in the histogram as rectangles, while the data in frequency polygon is represented using a line graph. In the context of the histogram, we can say that the height of different points of a class interval is fixed. This shows that a class interval in the histogram has uniform distribution of frequencies. If we talk about frequency polygons, then you can see that the height of different points in a class interval is not fixed, which means that frequency polygon do not have uniform distribution of frequencies. In this way, with the help of frequency polygons, we can find an increase or decrease in frequency, that is trend. Similarly, frequency polygons also help in comparing two different figures of similar nature. Now, let's know how to make a frequency polygon without histogram. Here also, we will take the first class interval 110 to 120 before class interval 120 to 130 whose frequency is 0, and similarly, after class interval 160 to 170, we will take class interval 170 to 180, whose frequency is also 0. To make a frequency polygon, we need the middle point called class mark of the class interval. Therefore, we will get the class mark of each class interval. Class mark of class interval is equal to upper limit of class interval plus lower limit of class interval divided by 2. Therefore, class mark of 110 to 120 is 115. Similarly, class mark of class interval 120 to 130 is 125. Similarly, we will find the class marks of all the class intervals. Now, we will draw x-axis and y-axis and represent class marks on x-axis and frequency on y-axis. Taking an appropriate scale on both axes, we will represent different points taking class marks as x-coordinates and its corresponding frequency on y-coordinates. Here, we will represent point O with coordinates 115, 0. Similarly, we will represent other points like this. Now, we will complete the frequency polygon OPQRSTU by connecting all the points with line segments. In this way, we can obtain a frequency polygon even without a histogram. The table below gives the class interval of different widths and their frequencies. Try yourself to represent it in a frequency polygon. So today we learnt about frequency polygon. We will see some interesting examples related to it in the next video. Today we will see examples related to frequency polygon. Nitin started the business of publishing books. Production of books in the first few days of business is as follows. Represent the business progress as a frequency polygon without the help of histogram. We need class marks to create a frequency polygon independently. We know that the midpoint of class interval is called a class mark. Can you tell how we find the class marks? Think. Absolutely right. To find the class mark of a class interval, we divide the sum of upper limit and the lower limit of class interval by 2. Like, class mark of class interval 0 to 6 is 3. Similarly, find the class mark of all the class intervals. Now, we will represent class intervals on x-axis, means days, and frequency on y-axis, means number of books. For this, we have to choose the appropriate scale on each axis. We can take 1 unit is equal to 6 days on the x-axis and 1 unit is equal to 240 books on the y-axis. We will then denote the class mark and their frequency of all the class intervals from the points B 3 and 240, C 9 and 600, D 15 and 960, E 21 and 960, and F 27 and 1080 respectively. After this, we will connect all the points to complete the frequency polygon. We will take an imaginary class interval -6 to 0 before class interval 0 to 6, for which we will extend the x-axis in negative direction. And the class mark of this class interval will be -3. Since books have not been produced in this imaginary class interval, the frequency of this class interval can be taken as 0. Now, we will represent point P on the coordinates -3, 0 and connect point P with point B by line segment. This line segment intersects the y-axis at a point, which we will call point A. Similarly, suppose that even after the class interval 24 to 30, The class interval with zero frequency is 30 to 36, whose class mark is 33, which we will represent as g of 33 and 0 on x-axis. Now, we will connect point F and point G by line segment. Sometimes, imaginary class intervals do not exist, as the number of days here cannot be less than 0. Therefore, the class interval -6 to 0 does not exist. In such cases, we extend only that much part of line segment which is on the right of the y-axis, like here, we will draw AB and ignore PA. Then, we will connect y-axis and intersection point of this line segment to origin O. Like here, we connect A with O. In this way, we get frequency polygon OABCDEFG. By looking at this frequency polygon, we can get various information like the production of books increased till the 15th day, then remained steady till 21st day, then increased till 27th day and then decreased. Can you find out what rate the production of books increased from 7th day to 15th day? Do discuss it with your friends and find out the answer. So today we saw an example related to frequency polygons. In the next video, we will see another interesting example. Today we will see an interesting example related to frequency polygon. Regular checkup is done for the health of the employees working in a medicine factory. A doctor was called to the factory to get the employees' health checked. The doctor divided the staff into two age groups before examining the employees aged 25 to 40 and employees aged between 40 to 60. After this, doctor examined the blood pressure of all employees and made the report shown. Draw the frequency polygon for the blood pressure of both age groups on the same graph. Pause the video and try yourself first. Let me tell you, here we have to show both age groups in the same graph. For our convenience, we will draw a frequency polygon without drawing a histogram. First, we will find the class mark, that is, the middle point of each class interval. For this, we will divide the sum of the upper limit and lower limit of each class interval by 2. Like the midpoint of class interval 90 to 100 is 95. In the same way, we will find the class marks of all class intervals. Now, before taking class interval 90 to 100, we will take class interval 80 to 90 with frequency 0, whose class mark is 85. Similarly, we will take class interval 180 to 190 with frequency 0, whose class mark is 185 after class interval 170 to 180. In this way, the class mark is from 85 to 185. Therefore, we will represent class marks on x-axis, which represent blood pressures, taking 1 unit is equal to 10 mm of Hg. Since here start point is 85, therefore we will not represent class mark from 0 to 85, which we will represent by a kink mark. If we observe the number of employees in age group 25 to 40 and age group 40 to 60, then here to represent the frequency of class intervals, we will take 1 unit is equal to 6 workers, because many numbers are multiple of 6 and other numbers can also be easily represented by this scale. Like 15 can be represented as 2 unit plus 1 by 2 unit, means represented as 2.5 units. Therefore, on the y-axis, we will take scale 1 unit is equal to 6 workers. Now, we will draw a frequency polygon to represent the number of workers in the age group of 25 to 40. For this, we will consider class mark as x coordinates and number of workers as y coordinates. In this way, we will represent number of workers in age 25 to 40 respectively as given. We will connect all this with continuous line segments, which gives us frequency polygon ABCD EFGHIJK, which represents the number of workers in age group 25 to 40 and their blood pressures. To represent that, this polygon is made up of continuous line segments, which represents the number of workers in the age group of 25 to 40. We will write symbol like this. Now, we will draw the frequency polygon to represent the number of workers in the age group of 40 to 60 years. The class marks and the frequency of imaginary class intervals are the same in both cases, so their coordinates will be same in both cases. Hence, the first point will be A, 85, 0 and the last point K, 185, 0 in both the cases. In this way, different points to denote the number of employees between the ages of 40 and 60 respectively will be as follows. We will connect all the points with dotted line segments, which gives us the frequency polygon A PQRSTUV WXK, which will denote the number of employees aged 40 to 60 and their blood pressure. To show that a polygon made with dotted line segments represents the number of employees between 40 and 60 years of age, we would write the sign as follows. Can you get any information from this graph? Think. Let me tell you, we can get various information from this graph. For example, if we look at the vertical line of blood pressure 95, then it is known that those employees whose blood pressure is 95 mmHg are lower in age group of 25 to 40 as compared to those in age group of 40 to 60. We can also see that in both age groups, maximum number of workers have blood pressure as 135 mmHg. Here we see that point S and point G are on the same horizontal line, which means that the number of workers in age group 40 to 60 with 125 mmHg blood pressure is equal to the number of employees in age group 25 to 40 with blood pressure 145 mmHg. Now, find the answers to the following questions yourself. Compare the number of employees of both age groups whose blood pressure is 105. How many such employees between the ages of 25 and 40 have blood pressure of 125? So today we saw another interesting example related to frequency polygon.